Hey guys, this is Structures Explained, and in this video we are going to talk about concrete stairs. To be very frank, staircase reinforcement scares me. Its detailing is not simple like beams, columns and slabs. In this video we will simplify everything about stairs, so stick around till the end to know all about concrete stairs. This video is divided into two parts. First is general terms used in stairs and loadings on them, and second is typical reinforcement in a stair flight. Let's consider only a single flight of stairs. A typical stair consists of three parts, two landings and one base slab. Base slab has steps in which the vertical part is called riser and the horizontal part is called tread. Effective thickness of the base slab is considered from the bottom of the riser till the face of base slab. The distance between the supports is the span L. In this case, we have two types of beams used for stair support. First is floor beam and second is mid-landing beam. Let us first understand the free body diagram of stairs. Assume a stair to be like a slab, resting only on two ends, just folded at 2 points. The ends which support the stair can be two beams or two concrete walls or a combination of wall and a beam. In this video, we will consider our stair supported on two beams. Let's talk about the loads which are applied to the stairs. First load is the self-weight of the stair, which is determined by the thickness of the landings and flight slabs and the steps. Second type of loading stairs take is the finish applied over them. Finish can be heavy in the form of decorative stones or negligible in the form of paint. Last in the loading comes live load, which depends on the function the stair serves, which is generally vertical movement of people. To resist all the stresses and deflections, reinforcement is provided in the stairs. Let us look at the typical reinforcement which is provided in them. In a stair flight, top reinforcement will be required at supports to resist the negative bending moments and bottom reinforcement will be required at midspan to resist the positive bending moments. For the two junctions between flight and the landing, special detailing is provided to resist the stresses generated there. Let's understand the detailing of rebars one at a time. Starting with the main longitudinal reinforcement, the first rebar starts from the bottom support, stays at bottom face for lower landing and base slab, and goes to top face of upper landing. The second rebar starts from the lower support, stays at the top face of the lower landing, and merges with bottom rebars in the base slab till 1/3 of the span length. The third type of rebar starts from the upper support, runs at top face of upper landing and stays at top face of base slab and merges with bottom face of lower landing. This bar can be curtailed in base slab if it is not required in that portion. The fourth type of rebar starts from the upper support, runs at bottom face of the upper landing and goes to top face of base slab till 1/3 of span length. If additional layers of reinforcement is required by design, it will be added to existing configuration with appropriate development lengths. To tie together the main reinforcement, transverse reinforcement is provided in landings, base slab and steps as per design. The steps can be provided with bent step bars having a single bar to prevent creep and shrink edge cracks. That's it for this video. If you enjoyed this video and found it useful, hit that like button and comment below your thoughts or questions regarding the video. More such explain